to 32 ATP. This is a very, very efficient cellular process and obviously very essential to the functioning of our body. And it's just amazing, like, to think that this is happening, you know, several times, more than we can imagine, in our body, just every second. It's fascinating. I am in awe whenever I teach this to a student, or whenever I have to, you know, explain it in an exam even. Like, it's a pretty cool process. Now, there's one more thing I just want to go over. So that's pretty much cellular respiration covered, the 3 steps. As I said, I didn't go into too much detail. I just covered the bare essentials, just the amount of ATP produced, and just basic comparisons. But now I just want to talk about ATP and how much energy it yields. So we have our ADP plus P goes to ATP plus H2O. Now in this reaction, the delta H is positive 30.5 kilojoules per mole. So what that means is 30.5 kilojoules are being added into this reaction to produce 1 mole of ATP. And that 30.5 kilojoules is stored in this bond. So when I want to use the energy that I've just manufactured, what do? Well, obviously I do the reverse reaction. So the reverse of this reaction happens within the body. So ADP, or ATP rather, plus H2O goes to ADP plus P. So what's happening is, this guy is saying, hey, I'm going to break up this energy so it can be used, whether it's in the muscles, whether it's being used to think. It's this bond that's being broken to harness the energy. And obviously, delta H is going to be negative in this situation because I'm losing energy from the system. If we consider the ATP to be the system and we want to get energy out of it, the delta H is going to be negative kilojoules per mole. Awesome. So pretty much in this situation, I'm putting energy into my ATP, therefore my delta H is positive 30.5, and then I'm breaking this bond by adding water. Water's part of this reaction. My delta H is negative. So you can deduce that this is an endothermic process because I'm putting energy in to manufacture the ATP, and this process here is an exothermic process because I'm harnessing the energy. And the energy that I'm putting, like how this is all fueled, is the energy that comes from the 3 steps of cellular respiration. So as you can see, it's a very, very intricate biological process, but it's also a very, very imperative one for the functioning of our bodies. Thank you, and I hope you enjoyed the tute. A few more to come on a few other chemistry and physics topics. Thank you.